everyone, it's Mrs. Gandro, and I'm here with my first installation of one of my favorite mathematical concepts, and that is transformational geometry. And tonight we're going to take a look, or begin to take a look, at translations. So what we want to step away with, our learning objective for tonight, is that we're going to be able to determine what properties are preserved when given a translated figure. So we're going to take a look at some properties tonight. So we should know that a translation is a transformation in which you slide a figure from one position to another without turning it. And translations are often called slides. So you can see here I have triangle ABC, and I am sliding it. And when I do slide it, it's going to end up as triangle A prime, B prime, C prime. And I'm going to talk to you a little bit more about prime notation. Also, translations are considered to be a rigid motion. So what does rigid motion mean? It means that it's going to stay exactly the same as we move it. And I'm going to do a little demonstration in class so that you can see the difference between rigid versus non-rigid motion. So as we mentioned, translations are often called slides. So let's take a look and think about think of a person going down a slide. And I want you to think back to the video that I showed you a couple nights ago where I slid down the slide. So what happened to me as I went down the slide? Did I grow longer? No. Did I get shorter? No. Did I get wider? No. Did I get skinnier? No. And did every part of me move the same distance in the same direction? So did I start at the top and like my whole entire body came down the slide? So yes, I moved in the same distance in the same direction. And this will be true of this little boy too. If he slid down the slide, he's exactly the same at the top as he will be at the bottom. And this is a concept called congruence. So we can say that the boy will be congruent at the bottom. So when we take a look at translations, there's a couple of key concepts here that come in mind, and one of them is congruence. So with congruence comes corresponding parts. Another great mathematical term. So corresponding parts are parts that match up. Parts of figures, I should say, that match up. So, for example, and we talked about corresponding parts a little bit in our discovery, and we also talked about congruence a little bit in our discovery activity that we did in class. So, angle A matches up to angle A prime. And this arrow means that it maps to, or matches up to. So now let's take a look at angle B. We can see that angle B maps to or matches up to angle B prime. These are corresponding parts. And angle C matches up to or maps to angle C prime. So now let's talk a little bit about congruence, because corresponding parts should be congruent if the figure is going to be congruent. So we can say that the symbol for congruent, this is a symbol, is an equal sign with a little wavy sign above it. And we can say that angle A is congruent to angle A prime. And angle B is congruent to angle B prime. And angle C is congruent to angle C prime. Now we can also take a look at the segments. AB is corresponding and it's congruent to A prime, B prime. So AB is congruent to and corresponding to A prime, B prime. And I can take a look at AC. And AC is congruent to and corresponding to A prime, C prime. And BC is congruent to B prime, C prime. So those are corresponding parts, and they also happen to be congruent. So we have a lot of mathematical vocabulary here, including prime notation. And you've heard me talk about prime notation. And what prime notation means is that it's an image. So this is the original figure, and this is the image. And how do we know it's the image? We know it's the image because we've got this little mark right here, and that indicates that it's prime notation. So lots of vocabulary here. We have congruent, we have corresponding parts, we have prime notation, rigid motion, all good stuff, all awesome geometry stuff here. So when we translate a figure, every point of the original figure is moved in the same distance and in the same direction. So we just talked about corresponding parts, we talked about congruence, and now we're going to talk about the movement of figures and what it is to translate something. So we have triangle once again, ABC, and we have triangle A prime, B prime, C prime. And we're going to talk about the size of the triangle, once again reinforcing the concept of congruence. So what do we notice about triangle A prime, B prime, C prime compared to triangle ABC? Well, we can say that they're the same size, they're exactly the same, and that means that they are congruent. Exactly the same size and shape means that they are congruent. So therefore, we can say that triangle ABC is congruent to triangle A prime, B prime, and C prime. Now let's take a look at the corresponding segments. So starting off with BC. I know that BC is 2 units, and B prime C prime happens to be 2 units. So therefore I can say BC is 2 units, B prime C prime is 2 units. So therefore I can say BC is congruent to B prime C prime. Well, let's take a look and see if that's true for AC. AC is 2 units. A prime C prime is 2 units. So AC is 2 units. A prime C prime is equal to 2 units as well. So therefore we can say AC is congruent to A prime C prime. Now let's take a look at the last, AB. And let me use a different color here. I'll use a little blue here. AB. So if we notice that AB goes diagonally through 2 boxes here, or 2 units, A prime B prime goes diagonally through 2 boxes as well. So we can say that AB, sorry about that, is congruent to A prime B prime. Once again, using that mathematical notation. So let's talk about the corresponding angles. And let's see if they're going to be congruent or not. Well, we did an activity where we talked about corresponding angles and congruence. So I'm pretty sure that they're all going to be congruent. So angle A matches up to its corresponding angle A prime. So we can say that angle A, and if I were to measure it with a protractor, they will indeed be congruent. So A is corresponding and congruent to A prime. B is the same. Angle B is congruent to angle B prime. And C, angle C, is congruent to angle C prime. So the takeaway here is that if all of these corresponding parts are congruent, then the shapes must be congruent. They're going to be exactly the same size and exactly the same shape. So now we talked about congruence. We're going to talk about movement a little bit. Movement. So we're going to move the shape, triangle ABC to triangle A prime, B prime, C prime. So we're going to be looking at the distance and direction. So what I want to find out here is I have point A here, and I want to get to point A prime, or vertex A. Let's be mathematically correct here. So how far left or right, and how right, and 6 down, I end up at A prime. Well, let's see if this holds true for the other points as well. So B, 1, 2, 3, 4 right, and 6 down. And let's give it a go with vertex C. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, indeed, 4 right, 6 down. And so what can we say about these two? What can we say about the movement? Well, every point in the triangle ABC, moves 4 units right and 6 units down to match up to triangle A prime, B prime, and C prime. So finally, we're going to take a look at the orientation. And orientation means the order of the letters. So we're going to take a look at comparing triangle A prime, B prime, C prime, the image, compared to the original triangle ABC. And so what we mean about the orientation is that if you think of a clock, and if we were to move amongst the clock, sorry, that's the bell, we're moving clockwise around the clock. So we're going to do the same thing here. So we're going to move from A to B, B to C, and then C to A. So A to B, B to C, then C to A. Well, let's see if that holds true with A prime, B prime, and C prime. I move A to B, B prime to C prime, and C prime to A prime. So indeed, I move from A prime to B prime to C prime, and then back to A prime. So we can say that the orientation is the same. So let's take a look at the properties that are preserved under translation. Properties that are preserved. So we know that the angles have the same measure. So angle to angle, they have the same measure. And then line segment to line segment, they have the same length. And then thirdly, we have orientation. The only property that is not preserved happens to be location. And so what we mean by location is if we take a look at triangle ABC, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. We start off in quadrant 2, we end up in quadrant 4. So the location is not the same. So what I want you to do is I want you to take away and think about this for a little bit. I want you to think about 3 things that you can come away with when we talk about translation. So you might want to talk about the effects that a translation has on an object, maybe talk about the orientation, talk about the movement. So I want you to come to this class tomorrow prepared to discuss 3 things, and your 3 things might be different than somebody else's, to discuss, and that you notice about translation. So thank you everyone for being an awesome audience once again, and I will see you tomorrow. Have a great night.